Okay, welcome back, student. Now this will be the third part of chapter 3, physics, electricity of MBOSE syllabus. And today we'll do the topic of Ohm's law. And this also is very lengthy topic. But in your textbook it looks very short, but I'll make it lengthy. But that lengthy is not from outside the textbook, it is within the textbook. But all those topics which is not included in Ohm's law, I'll include it here. Because in your textbook they just like shuffle here and there, and I'll make it serially. Okay. Then in last video we have talking about charge, and then electricity and electric potential. Okay, and some others. But now we'll do about Ohm's law. And what is this Ohm's law? This Ohms is the name of a person. Okay, Ohm's law, and he's the one who invented first this law. That's why I give him Ohm's law. They give this law, and this law is a law which I'm talking about the relation between. This law is talking about the relation between the electric current and the electric potential. How they are related to each other. Remember here, whenever the applied potential or whenever the current flows through a conductor, it is always directly proportional to the applied potential. I mean, how much you apply the potential, then that much is the electric current flows. If the electric potential is increasing, what happens to the electric current? If the electric current is increasing, what happens to the electric potential? This law is telling about that. I mean, how electric current and electric potential are related. I mean, as the electric potential is increasing, then how much is electric current also increase or decrease? We will look according to this law. If the electric current is increased, whether this electric potential is increased or decreased, we will look by this formula. But remember, this law is valid only for a pure metal. It is not valid for all. It is not valid for semiconductor, and it is not valid for alloy. Okay? Because this law, when we do an experiment, we'll get a relation between electric potential and electric current always uniform. I mean, not uniform, it is always straight. Then, according to Ohm's law, electric current is directly proportional to the electric potential. I mean, as the potential is increasing, then electric current also is increased. According to this law, if the electric potential is increased, if you supply more electric potential, then it means the electric current produced also is very large. That is according to Ohm's law. Okay, but this law is not valid for all the materials. Okay, and also this law is not holds good at different temperature, because at different temperature, the value of that material, I mean the nature of the conductor, will change. At different temperature, the nature of the conductor or the wire are changing. Then at different physical condition, means when the temperature, pressure and density are changing, then the nature of the conductor also change. But Ohm's law does not consider about that. It says provided that the physical condition remain the same, meaning you have to consider that the physical condition, meaning the pressure, the temperature, the density should always remain the same, means at room temperature. We will study at room temperature in chemistry. Okay, let's try first the statement of this law, then we'll go for also that you understand. Okay, what Ohm's law said. Okay, I'll explain you. I'll draw first a diagram here. Let's say this is a conductor. Let's consider this as a conductor. Now this conductor is of the cross section of this conductor, mean this part, the cross section of this is as area A. The cross section A, mean area of cross section. And let's say the length of this conductor is L. And let's say this conductor is connected to a battery. We will come to that. Don't worry, we'll come what is this battery and what is this cell. After this topic of Ohm's law, I'll come to electric circuit. When we do that circuit topic, then we look what is that battery and what is that cell and what is the resistor. So many things are there. Okay. Now let's say this conductor is connected to a battery, Okay. Now look here. This battery means to supply what? To supply electric potential. Remember, battery is the one that supply electric potential. Let's say he give this battery has let's say this battery has 12 volt. 12 volt is electric potential. Now he supplied. Now it flows. Now it's supplied to this conductor. Now again, if this electric potential I'm increasing. Okay, I'll put here 18 volt. Now what happened to the current flows? If I supply 12 volt battery, then how much is current flows on this conductor? And if I supply 12 volt battery, how much is the current flows on this conductor? And that is what Ohm's law said. Here, as the voltage, as electric potential are increasing, then electric current flows through the conductor also increase. That's meaning of that when this electric current flows through a conductor, this conductor. Okay, let's say this is a conductor. When a current flows through a conductor, it is directly proportional to the supply voltage. What means that's directly proportional? Means as the supply voltage is increasing, then the current also increase. That's the meaning of that. Okay, let's write this statement. It states that let me drop this diagram. Okay, it's very difficult now. Why? I don't know. Let me pause the video, drop this one. Okay, what Ohm's law said? It states that when no need to write when. It states that the current flows through. It states that the current flows through a conductor. It states that the current flows through a conductor or wire is directly proportional. Is directly proportional to what? To the supply voltage. Provided, now please check this part. Provided that the physical condition, the requirement of physical condition, that is temperature, pressure and then speed remains the same. Okay, below what this means. It states that the current flows through a conductor. Okay, we have drawn that conductor. Now this conductor, now current flows here. We already know the symbol of current I. The current flows here through conductor is directly proportional. Remember, this means equal in mathematics. Okay, it's directly proportional to the supply voltage. What's the meaning of this directly proportional? It means as the voltage or the electric potential are increasing directly, then current also increase. Then if current is increased, then electric potential also increase. Provided that the physical condition, that is temperature, pressure, density, remains the same. Remember, whenever you apply Ohm's law, remember the temperature, pressure, and density does not change. If example, I want to find the nature of this material. The nature of this material means that there is another nature that will be called as resistance. We will come below here, resistance. Look, that the resistance will change as the temperature also change. That resistance change as the pressure also also change. Then in that case, then this Ohm's law are different. If I said this conductor in this room, it has 10 ohm resistance. We will come to that what's that ohm. Okay, 10 ohm resistance. Let's say this conductor, and in this room, this conductor has 10 ohm resistance. Now if I carry this conductor into a different place which are very hot, okay, in that place where the temperatures are very high, remember that the resistance of this conductor also become high. Then in that case, then this law is not valid, because at different location it has a different value. Then if we want to find what's the temperature of this, we have to tell at 25 degrees Celsius, the temperature of this conductor is 10 ohm, or at 15 degrees Celsius, the temperature of this is 8 ohm, example. Okay, then this Ohm's law is not valid when the temperatures are changing. That's why I said, provided that the temperature, pressure, and density remains the same, it should not change. If it's changing, then experiment will change. We won't get the same answer. Now let's write this statement in terms of formula. The current flows through conductor. What's the symbol for current? Okay, that is mathematical. I can write in this. They give some question like this. Write mathematical expression of Ohm's law. Okay, mathematical expression of Ohm's law will be this. That is current. Current is the symbol for current? I. You already know what's the symbol for current? I. That is, current flows through a conductor is directly proportional. What's the symbol for directly? Directly proportional to the supply voltage. Supply voltage will be electric potential, volt. Or I can write this one like this. Or I can write V is directly proportional to I. Because as V is increasing, I also increase. Then as I is increasing, we also increase. That is Ohm's law said. Now this you have been in previous class. When there is proportionality, what we have to do? Remove this proportionality. We got V is equal to. Now remove this proportionality. We got some constant value, some constant there. Okay, that constant will be I. Then what is V? Electric potential. What is I? Electric current. And what is this R? This is a constant of this proportionality. Okay. Now this will be the mathematical expression of Ohm's law. Where what we have to tell what is this? Where I is the constant of proportionality. Where R is constant of proportionality, and this constant of proportionality has a name. That name is called electrical resistance. Electrical resistance. And we will talk about what is this electrical resistance. What it says R is constant of proportionality, then it has a name, electrical resistance. And what is this V? Electric potential. And what is this I? Electric current. Okay, then here I have this. Now take this I this side and get R is equal to, take this I this side, because here is a multiply, and if you take this side change to divide, then R is equal to V by I. Now this will be the formula for resistance. Electrical resistance, mostly we call it resistance only. Electrical resistance. And this electrical resistance here, sometimes we call as load resistance, or sometimes we call as external resistance. There's two types of resistance, that is external and internal. That internal resistance you will do in higher class. Okay, but here we will deal only with this general electrical resistance. Okay, then R is equal to V by I. Now, what is this V by I? Now, what does I mean of V? Electric potential, do you remember? Okay. Now, what is SI unit of V? Electric potential. The SI unit of V is volt. SI unit of V is volt. That's SI unit of electric potential. And the SI unit of current is ampere. SI unit of current is ampere. Then we can write SI unit of R. What is R? Electrical resistance. As unit of R is electrical resistance. I can write here as volt per ampere or volt per ampere. But it has a specific names for this one, that is ohm. What is the unit of electrical resistance? Ohm. And the symbol for this will be symbol for ohm. This one. What is the unit of electrical resistance? Ohm. What is the unit of electrical resistance? Ohm or volt per ampere or volt per ampere. Now we'll come to what is this electrical resistance. Electrical resistance, what's the meaning of resistance? Resist means against something. Resist means against something. Or I can give you under words. Electrical resistance. Resistance means the obstruction. Obstruction of what? Now whenever a current flows through a conductor, let's say this is conductor. Now current flows on this conductor. Now is there any obstruction? Obstruction means those who are against that flow. If you move from one place to another place, what is your obstruction? Your obstruction is one thing is tire. I cannot go too much far. And one more thing is, if too much crowd are there in that road, then you cannot go very fast. You have to move slowly. And that also will be the obstruction. In obstruction means someone who opposes you to move. Then here, electrical resistance is the one that opposes the flow of current. Mean who give the hindrance or the obstruction to the flow of current? Who give that? The nature of the conductor. This conductor that have their own nature, then that will give the obstruction to the flow of current. Now what is electrical resistance? I can give you a question. What is electrical resistance? What is electrical resistance or what is resistance? Electrical resistance, I already told you just now, means the opposing to the flow of current. Who oppose? Not you and me. Who oppose? The nature of the conductor. Because that current flows on the conductor. Even in our body also sometimes when we by mistake we touch the wire, we got shocked. And even though our body also has a resistance to the flow of current. Okay, what is the answer for this? What is electrical resistance? The obstruction flow. The obstruction given. The obstruction. What does it mean? Obstruction means opposing or against. The obstruction given. The obstruction given by the conductor. The obstruction given by the conductor to the flow of an electric current is called electrical resistance. It's called electrical resistance. If we ask an example of electrical resistance, this definition will be enough. And if they ask me what is unit, ohm, and remember electrical resistance is a scalar quantity. Remember that it is not a vector. And right here, it is a scalar quantity. It does not have a direction. Okay, then after this, now we'll come to some part of this still below here only. Let me write fast this one. Okay, now we just finished that definition or statement of Ohm's law, and then the definition of electrical resistance. And I already told you what is a sign of electrical resistance, that is ohm. And here the question is define one ohm. And also let me give you like this question. State the sign of electrical resistance and define it. The answer for this. State the sign of electrical resistance, you already know what is as a sign of electrical resistance, that is ohm. As I did, it will be ohm. But the question is, and define it. It means define one ohm. Okay. To define, let me do like this. We know What's the formula for electrical resistance? Just now we got it that R is equal to V by I. Is this a formula for electrical resistance? Electrical resistance R is equal to electric potential by current. Now let electric potential is equal to 1 volt and current I is equal to 1 ampere. Then therefore what is R? In place of this V I put here 1 volt. Then in place of this I put here 1 ampere. Now what is electrical resistance? As I need ohm. Now 1 volt by 1 ampere is equal to 1 ohm. Now how to define it? Thus electrical resistance means electrical resistance is said to be 1 ohm. When 1 ampere of current, who flows in a conductor? Current. Electrical resistance is said to be 1 ohm when 1 ampere of current flows through conductor under a potential difference of how much? 1 volt. Or 1 ohm is said, resistance is said to be 1 ohm. Resistance is said to be 1 ohm and 1 ampere of current is said to be when 1 ampere of current flows through a conductor under a applied potential of 1 volt or under a potential difference of 1 volt. You can find that. Now what is define 1 ohm? Now define electrical resistance is said to be 1 ohm. Thus electrical resistance is said to be 1 ohm. If they ask an exam, define it also, this will be the answer. Electrical resistance is said to be 1 ohm when 1 coulomb. No? When 1 coulomb. When 1 ampere. So to be 1 ohm when 1 ampere of current flows through a conductor under a potential under a potential difference of 1 volt. I will ask you what is say SI unit of electrical resistance and define it. This will be the SI unit and this will be the definition. Electrical resistance is said to be 1 ohm when 1 ampere of current flows through conductor under a potential difference of 1 volt. And this will be the definition of 1 ohm. Then now we come to next part, that will be again the reciprocal of resistance. What is if I like this? Now this I are right up, now this V are right down. What I'll get? I'll get like this. 1 by R. Right? Because from below here we got 1. Then if I take I from up, I by V, then this also will be 1 by R. Now this 1 by R is equal to how much? Now this 1 by R is equal to G. I by V. Now this G is called electrical conductivity. Electrical conductance. This G is the electrical conductance. Now, what is electrical conductance? The reciprocal. 1 by R means reciprocal. The reciprocal of resistance is called conductance. But this you don't need. Just know what is the reciprocal of R. Reciprocal of R is the electrical conductance. Okay, what is electrical conductance? The reciprocal of the electrical resistance. The reciprocal of electrical resistance is called electrical conductance. Okay, and now we'll come to another part, but still it's about resistance. Okay, let me go first this one. Okay, now I finished to define the unit of electrical resistance, and now we'll come to the factors affecting. The factors electrical resistance. The factors affecting electrical resistance. Mean which parameter that affect the resistance? Mean that affect that the nature that oppose the flow of electric current. Okay, when is that resistance will increase and when is resistance will decrease? Okay, number one. If in exam they ask you what are the factors affecting electrical resistance, just write this. But if they will ask explain, then you need to do some explanation. Okay. Now the factors affecting electrical resistance are number one, that is length of the conductor. Length of the conductor. Okay, the factors that affect electrical resistance are length of conductor. Ask the conductor, what was the meaning of this length of conductor? Okay, I write out that is. And then number two. Number two, area of cross section. Area of cross section or size of the conductor. And write here number 1, 2, and right here number 3. Length of conductor, area of cross section or size of conductor, and then one more. What else? Temperature. Temperature of the and surrounding. Because I've told you from the beginning that electrical resistance will change at different locations. That's depend on the temperature. Okay, then number 4, nature of the material. Nature of the material. Because different material has different electrical resistance. Copper has different value of electrical resistance, aluminium has different value of electrical resistance, and silver has different value of electrical resistance. Okay, then what's the nature of material? You will go deep on this nature of material in higher class. Okay, but here we will just do in brief what is this nature of material. Okay, now let's look at this one. What are the factors affecting electrical resistance? These are the 4 factors. One is length of conductor. Number 2, the size of the conductor, being big or small. Okay, big or small. Okay, for big, what happened to electrical resistance? For small size, what happened to electrical resistance? And length of conductor, if the length of the conductor is increasing or decreasing, what happened to electrical resistance? We will look about that. Then temperature surrounding, if the temperature is increased, what happened to the electrical resistance? And nature of material. This we cannot be changed because this is different for different particular material. Okay, length of conductor. Here we can write this. That is what's the meaning of this. Now, as the length of conductor is increasing, or as the length of conductor is more, then the resistance also will be more. Why? Example, I'll give you. If you travel for 10 meter, will you get tired? I don't think so. You will tired for 10 meter travel. But if you travel for 1 kilometer, will you get tired? Can't you run with the same speed? If for 10 meter you run 2 meter, 3 meter per second, and for 1 kilometer, can you run with that 1 meter, 2 meter per second? I don't think so, because if you travel long distance, you will get tired, and for short distance, you won't get tired. And similarly for here, if the length of conductor is increasing, then so many obstruction, then so many things that current has to pass. Then in that case, then if we total all that obstruction, okay, example, this is a conductor. Now one more conductor here, small conductor. Now if the current flows from here to here, this distance are very short. Then the obstruction here will be have some value, obstruction here have some value. If you total them, it won't be reached because here so many obstruction up till to reach here. Then if you total them all, then it has a large value of obstruction. Then as the length of conductor is increasing, then electrical resistance also increase. Okay, what we write here? Length conductor. That is electrical resistance is directly proportional to the length of the conductor or the wire. Okay, what's the meaning of this? The length of the wire. Now, electrical resistance is directly proportional. Means as the length of conductor is increasing, as the length of conductor is more, then electrical resistance also will be more. Then this we can write as in mathematical form that R is directly proportional to L. Electrical resistance is directly proportional to L. L means length of conductor. Okay, we will write this one as okay. We put this as equation 1. Now what mean is as the length of conductor is increasing, electrical resistance also increase. Now come about this one. Now area of cross section or size of conductor, as the size of conductor will be more, then remember electrical resistance will be less. Why? I'll give you an example. If I give you two roads, one is a small road and one is a big road, then in small road and in big road, which road you would prefer to go? Because in big road you can travel so fast, no one is disturbing you. But in small road, it is too much congested that you don't want to go from there because there are so many obstruction. But in big road there are so many space you can go freely, means you can move easily. Then the resistance are very, very small. But in small road there are so many obstruction because you don't have a space to move. Then there are so many obstruction. Then as the size of conductor are large, remember that. Mean area of cross section of conductor are large, then the resistance will be less. First meaning of this, that is electrical resistance is inversely proportional. Electrical resistance is inversely proportional electrical resistance is inversely proportional to the size of the conductor. Okay, we'll write mathematically that R is inversely proportional to 1 by area. This A means the size, means this one, this circle here. Okay, when we draw a conductor like this, now these are the area of cross section or the size. Then let me put this as equation 2. And then temperature of surrounding. Remember this one. As the temperature increases, the resistance also increases generally. But this is not valid and this is not hold good for all the material. For pure metal, as the temperature increase, resistance also increase. But for semi-metal, that will be different, and for alloy that will be different. For different materials, then the resistance is different. Okay. Then for pure metal, as the temperature increases, as the temperature rises, electrical resistance also rises. Okay. Then this they already given in textbook. They just give this. Generally, as the temperature rises, electrical resistance also increase. Then they write this is not hold good for all the material. Okay, they give some point that for alloy this does not valid. Okay, for semi-metal these are different. Then you please check from the textbook about this temperature of the surrounding. As the temperature increase, resistance also increase just for a pure metal. Okay, and nature of material. What's the nature of material? Mean for different metals, different material, they have their own nature, and this nature will be. We will come to that. But after combining these two equations, we will get what is the nature of material. Okay, I'll draw this one. Now we just finished that factors affecting electrical resistance. Number one, we got R is directly proportional to L. As the length of conductor are more, electrical resistance also will be more. Then number two, number two is 1 by A. As the size of conductor are more, then the electrical resistance will be less. Okay, so meaning of this, as the area of cross section of conductor or the size of conductor are more or increase, then electrical resistance are decreases and small. Okay, remember that. Then this will be equation 2. Now let me combine these two. Combining 1 and 2. Combining 1 and 2, we have, okay, now R is directly proportional to L and inversely proportional to A. Now we got R is directly proportional to L and inversely proportional to A, combining this equation 1 and 2, and from here remove this proportionality, then we get some constant term that will be symbol rho. Okay, but look what is this one. What's the name of this? Rho. And the spelling for this R-H-O, not a ho, but pronunciation will be rho. Pronunciation will be rho. This one. Now, this will be the formula. Okay, where R is electrical resistance, you already know. Then L is the length of conductor, and A is the area of cross section. Then what is this rho? This is a constant of proportionality. Constant of proportionality. But it has its own. It has its name. Its name is electrical resistivity. Resistivity or specific resistance. Okay. Now what is this rho? This is the Greek alphabet. Okay, this rho is we just put as a symbol here. Then R is equal to rho into L by A. Then rho is a constant proportionality, or it has a name that is electrical resistivity or specific resistance. And this rho is a constant for a specific material. Look, resistance for this conductor at 10 degrees Celsius it has some value. At 20 degrees Celsius it has some value. It won't be the same. Mean as the temperature are changing, then resistance also will change. Then as the length of conductor increase, then R increase. Then as the size of conductor increase, then resistance are small. But this rho, this electrical resistivity or specific resistance, whether the conductor are increased, whether the conductor are small in size or long in length, or whether we are carried from one place to another place, if the temperature are changing, the electrical resistivity remains the same. The specific resistance does not change. Because one, this rho is the nature of the material. If I'm the one, if here in this room I have this nature, maybe I'm very angry, but if I move to another place, will my nature change? I don't think so. I will change. The attitude of a person, or the nature of a person, or the character of a person does not change from place to place. It may vary somehow because it's a people character. Because people nature we cannot predict it 100%. But for material, if we take this conductor from one place to another place, it does not change. The atoms, the electron present here, it does not change. Then the nature of the conductor remains the same. Then resistance change as the size and the length, whatever it is. But this constant of proportionality or electrical resistivity or specific resistance does not change. Whether the size are increasing, whether the size are decreasing, whether the temperature are changing, whether the pressure are changing, specific resistance remain the same. Now this rho is the nature of the material. Nature of the material. But this, the formula to find this rho, there will be in higher class. Because for different material it's resistivity, so that can get the value of R. Okay, but here in class 9 we don't need that formula is not yet given in the syllabus. Okay. Then now from here, if I take this A this side, because this A is from denominator, if I take to the left side, it will change to multiply. Then we can write here as R into A. Take this A this side. Then if I take this L, it will change to denominator L. Then here I'll get rho. Now this will be the formula for rho. Then rho is equal to R into A by L. R into A by L. Now if they ask, okay, now let's look first here. SI unit. Now SI unit of electrical resistivity. SI unit of specific resistance or electrical resistivity. What's SI unit? What's SI unit of electrical resistance? Remember? Ohm. Okay, right here. Ohm. Then SI unit of area is meter square. Remember this? This you have do in class 9, in class 8, or in maths. The SI unit of area is meter square, and SI unit of length is meter. Then meter and meter cancel. Then we got SI unit is equal to ohm meter. Now what's the SI unit of electrical resistivity? It's ohm meter. And what is SI unit of specific resistance? Ohm meter. Because specific resistance is another name of electrical resistivity. Remember, electrical resistivity does not change on the size of conductor and does not change on the surrounding. Okay? But resistance are change depend on surrounding and change depend on the size of the conductor. Now what is the SI unit of electrical resistivity? Ohm meter. Now if I ask you to define electrical resistivity, define electrical resistivity. Definition of this, we will do like this. I'll take this formula to define it. Okay, I'll do like this. We know, or I'll take this one. Rho L by A is equal to R. Just interchanging this side and that side. Rho L by A is equal to R. Now do like this. Let L is equal to 1 meter, because L is the length of conductor and the distance and the length is always in meter. Then A is the area, let me take as 1 meter square. Then we get here, therefore rho, because here remaining 1, here also 1, then rho is equal to R. Now from here we can define electrical resistivity. Thus, electrical resistivity is equal to electrical resistance, or numerically equal to electrical resistance. When what? For a conductor of how much? For a conductor of unit length and unit area. Okay. Let's look this definition from the textbook. From the textbook definition of this. Okay. Now what is this electrical resistivity? Electrical resistivity is the amount of electrical resistance. Because rho is equal to R, right? According to this. Then electrical resistivity is the amount, it is the amount of electrical resistance under which the conductor, the length of the conductor is 1 unit and the size or the area of cross section is 1 meter square. What is electrical resistivity? It is the amount of electrical resistance under which the length of conductor is 1 meter and the area of cross section or the size of conductor is 1 meter square. That will be the definition. Maybe that definition you can read from your textbook. Okay. Define electrical resistivity, then this will be finished. Then, now what else left from this topic? Okay, let me recap. Okay, now we finish the statement of Ohm's law and the definition of electrical resistance. You already know that electrical resistance is the obstruction or the opposing nature of the conductor to the flow of current. Then electrical resistivity is the nature of the conductor. Electrical resistivity is constant for a particular material, and resistance is a constant at a particular temperature and is constant at a particular size of the conductor. Okay, but if the size of conductor is increasing or decreasing, then resistance also decreasing or increasing. Okay, then now we'll come to some formulas and some path which is made from here. Okay, then there is a one verification of Ohm's law, but that I will do after when I finish the electric circuit. Because in that we have to draw a circuit diagram. Then we are not yet finished to do what is a circuit diagram and what is a circuit. Then the symbol of electrical components also we are not yet do. Then I'll do after we finish that. Okay, but here we'll do some the formulas. The formulas, and we got that is R is directly proportional to L. That we write in first factors affecting electrical resistance. Then number 2, we got R is inversely proportional to 1 by A. Or we can get this formula, number 3. Or R is equal to rho L by A. Then we can get this also. R1 by R2 is equal to L1 by R2. Then this formula is coming from this one. Don't be confused. Okay. Then number 5, we get this R1 by R2 is equal to A2 by A1. Look, because R is inversely proportional to, if this is R1, then this will be A1, and here R1 will be A1. And if here is R2, then this will be A2. This formula also coming from here. Okay, now this form related to this formula, we'll do some problems, but that problem I'll do in another video. But here I'll just give you some questions that we'll try to answer by using these formulas. Okay. But remember, the problems or the question which I give you here, please remember. Because if I ask you, if the length of conductor is increasing, what happens to electrical resistance? Electrical resistance also will increase. Now if I said if the area of cross section of conductor is increasing, what happens to electrical resistance? It will be decreased. But now, if I said, remember, because once we take a wire or a conductor, once we increase the length, pull it, then the size of the conductor automatically it will decrease. You check in a rubber band, if the size is big, but once you pull it, it becomes thin, right? Once you pull it becomes thin. Then once the length are increased, then area are decreased, right? Then in that case, what happens to electrical resistance? In that types of problem, maybe they won't give you in exam, okay? Because that types of problem, we have to consider the volume of first case and second case should be the same. Okay, if in case they give that types of question, I'll give like this. Okay, I'll make a question. So that you just get a clue, the length of the conductor is getting double. The length conductor is getting double. What is the change in electrical resistance? What is the change in electrical resistance? What's the change in electrical resistance? Okay, first I'll do like this, a very simple question. First I'll do like this. Note area or size of conductor, area or size of the conductor are unaffected. Just assume if this is a rubber band or this is conductor, if I pull it, Once it's increasing in length, the sides are decreasing, right? But here the question said, if the length control is increasing, getting double, but area and such control are unaffected. Mean if I pull also, the sides remain the same. Okay, if I pull also, the sides remain the same. And in that case, very easy for you to answer. If the length of conductor is getting double, then resistance also getting double. Then answer from here will be resistance also get double. Resistance also getting double. That is 2R, I can say. Why? Since R is directly proportional to L. Means as L is increased, then R also increased. If L increased 2 times, R increased 2 times. If L increased 3 times, then R increased 3 times. If they said area or size control are unaffected, but if they don't say, then in reality, if we pull something, then if the length are increasing, the size are decreasing. Then in that case, we won't get the same answer. That will be different. Okay, same question I will make, but I don't think so that they will give you an exam. Let's do that types of question, because that question are a little bit lengthy to explain. Let's do that types of question where we do a problem related to this Ohm's law and this resistance. Okay, now one more question. If the area of the conductor R decreases, one more question. The area of cross section, not area, okay? Area of cross section. Area of cross section or size of the conductor R decreases. R decreases. Then what is the change in its electrical? Then what is the change in its electrical resistance? Then provided the length of conductor are unaffected. Remember this. Provided the length of the conductor are unaffected. Means same like this one only. Look, the area of cross section of such conductor are decreases. Means how if the size of this conductor are decreased, means smaller. Means smaller means when we pull the conductor, then only the size are smaller, right? But here is that the conductor are decreases in size. Provided the length conductor are unaffected, means the length remain the same. If in that case, we'll apply this formula. Means as the area are decreased, as A is decreased, then R will increase. Because look, I'll give you an example. And if R is equal to 1 by 4, one example, this one, then another R is equal to 1 by 2. Now let's say this is R1, this is R2, this is A1, and this is A2. Now here, A2, now here A1 is 4, and here A2 is 2. Now which one is greater? A1 is greater than A2, right? Because here is 4 and here is 2. But let's look what is R1 and R2. Here we got 0.25 and here we got 0.5. Now which one is greater? R1 or R2? Now R2 is greater than R1. Then we got here R1 is less than R2. Look, as the area is increased, resistance are decreased. As the area is decreased, then resistance is increased. Then what's the answer for this? The area of cross section of size conductor are decreases. Then what is the change in the electrical resistance? If it is decreased, then what happens to the resistance? If this is decreased, then this will increase. Then electrical resistance will increase. Resistance will increase. If they said decrease 2 times, then increase 2 times. If they said increase 4 times, decrease 4 times. Okay. If note this one. If the length contour are changing, sides are unaffected, then directly we'll use this formula. Then since R is inversely proportional to 1 by A. Okay. But if they don't mention this, provided the length contour are unaffected, then in this case we have to solve. And in that types of problem I will do together when we solve the problem related to this formula, and related to this formula in the next video. And okay, I'll give you one question. You do that question. Okay. That question is very simple. Similar to this only. Resistance of conductor L and resistance of conductor L is R. Resistance of conductor L is R. The length of the conductor becomes half the original. What is its new resistance? Okay. Answer will be option number A, R. Then option number B, 2R. Then option number C, R by 2. Then option number D, none of this. Okay. Now you do this question by your own. Then in next class we'll do the problem related to this formulas. Then after that we'll come to electric circuit. And after we finish the electric circuit, and again we'll do problem related to electric circuit. Then we'll finish the second part of this chapter. Then we'll start the last part. But that last part maybe I'll do 10 times per week, because according to the syllabus that last part I removed. Because still now we don't know which syllabus we have to follow. Whether we follow that syllabus which is given in 2020, or we have to follow that syllabus, previous syllabus. Okay. Thank you, and do like and share and subscribe, and share this video and subscribe it. Thank you.